Hi everyone, thank you for joining me here today. Today we're going to be going over the Chapter 2 Absolute Value Review. So let's go ahead and jump right into it. You are already given your review, but if you don't have one, you can get an extra one from the class website. Just go to the calendar and check out the Chapter 2 Absolute Value Review. So our very first problem says solve the equation 3x plus the absolute value of 3x plus 3 equal to 12. And now you always want to check for this extraneous solutions part, but let's just get down into it. Remember, so in order to break this absolute value apart, you're going to want to say 3x plus 3 equals 12 and 3x plus 3 equals negative 12, because an absolute value always equals a positive and a negative. So we'll subtract 3 here. So 3x equals 9. And we'll divide by 3. So x equals 3. Subtract 3 here. 3x equals negative 15. Divide by 3. X equals negative 5. Alright, and from there you always want to check your solution. So does the absolute value of 3 times 3 plus 3, does that equal 12? Well, we get the absolute value of 12 equal to 12, and we do get 12 equal to 12. So that one checks out. That one's okay. Now let's check out the negative 5 answer. The absolute value of 3 times negative 5, whoops, not negative 15. Go back. All right, so negative 5 plus 3, close absolute value, does that equal 12? So we're going to get the absolute value of negative 15 plus 3, so negative 12 equal to 12. And the absolute value of something means the distance from 0. So negative 12 to 0, that's 12 steps, so we get 12 equal to 12. So that also works. So both of our solutions work out. You always want to be careful, though. Always check for those extraneous solutions. Now let's go on to problem 2, solving the inequality. Graphing the solution. So always divide our, you always want to isolate the absolute value part first. So we're going to get the absolute value of 4 minus 3x, close the absolute value, greater than or equal to negative 4. Now this is an interesting one because you're going to have to read the inequality later. But pretty much we're going to put a 4 over here, and then 4 minus 3x, and that's going to be greater than or equal to negative 4. So we're going to have to understand what this means in the end. So we'll subtract 4. And we're going to get 0 equal to negative 3x. Sorry, not equal to. What is it? Greater than or equal to, which is greater than or equal to negative 8. And then we're going to get negative 3x. So divide everything by negative 3. And remember, when you divide by a negative when it comes to inequalities, you're going to flip that sign. So 0 is less than or equal to x, which is less than or equal to positive 8/3. So here we're going to look at this. And it said graph the solution. So here is 0. Put 0 right here, and then here is 8/3. We know it's going to be a solid circle because it's equal to, and you're normally going to shade in the middle. Well, let's kind of do some test points here. So this is basically going to be our solution area, the answers. So I could choose like 1. 1 falls in between here, and if I substitute 1 in to the function, I'm going to get 4 minus 3, which is 1. The absolute value of 1 is 1 times 2. And then is 2 greater than or equal to negative 8? Well, yeah, that works. Now let's choose something outside of this range. So let's choose like 3. So 4 minus 9, that gets me negative 5. And then the absolute value of negative 5, that gets me 5. So I get 2 times 5. That gets me 10. Is 10 greater than or equal to negative 8? Well, that's also true. So I also have this region over here. It keeps going over here. And this is what happens when you get the inequality and the negative values on the other side. You're going to have to check all these parts. Now let's also check -1. So 4 plus 3, that gets me 7. 2 times the absolute value of 7 is 14. Is 14 greater than or equal to -8? Well, that is also true. So I have all of these solutions as well. So my answers is all real numbers. All real numbers. So you have to read the inequality, but then you also have to understand, like, this was equal to a negative at the beginning. So you want to do those extra checks. Let's look on to our next problem. Admissions into a mass society requires applicant be between the ages of 32 and 46. Oh, write an absolute value inequality. The best way to do this is to kind of draw a picture. So here's 32, here's 46. Can they be 32 and 46? Yes, but they have to be anywhere in this range. So like, can they be 37? Yeah, that's okay. Can they be 49? No. All right, so we want to get the middle number. So that's going to be 39. And the range from 39 to either end is 7 steps in either direction. So when we write this, we're talking about the age. So the absolute value of the age minus that middle number, 39, close the absolute value, is less than or equal to, and I'm getting equal to because it's filled in circles, and less than because we're shaded right here in the middle. So less than or equal to that tolerance, which was 7. So that is my absolute value inequality. Number 4, let f of x equal 3x minus 4 and g of x equal the absolute value of x plus 3. Find g of 2. Well, let's figure out what g of 2 is first. So g of 2 is going to be the absolute value of 2 plus 3. Well, 2 plus 3, that gets me 5. So what this question is asking is, what is f of 5? Well, f of 5, in order to figure out f of 5, you come over here to f and you do 3 times 5 minus 4. So that's 15 minus 4. So I get a total of 11. So don't let this problem intimidate you. Just remember, what does the function mean, and remember your order of operations. Number 5, write an absolute value inequality to describe the graph. So we just did this in a word problem, but now we're going to do this right here. So we need to find a value that's in the middle. So it looks like right here, 0.5 works. So that's my middle number. We want to find that tolerance. So that's going to be 1, 2.5 in either direction. So then you just have to get that inequality. So if it's just a number line, you can just use x. So x minus 0.5, close the absolute value. It's not filled in. So the circle is not filled in, and it's shaded outside, so that means greater than, and then that tolerance, 2.5. There it is. Our next problem. Let's look at number 6. Write the equation for the equation graph to the right. So this is an absolute value, so I know I'm going to have the absolute value of something. Well, this is my origin. We want to move it 1 to the left and 1, 2, 3 up. So 1 left and 3 up. And I also want to take a look at the slope. So it goes down 1, 2, 3 over 1. So I have a slope of -3. Well, these are all the transformations. Now we can write the equation. Y is equal to -3 times the absolute value of x. So it's -3 because that's the slope, times the absolute value of x. Now we're going to go 1 left, so that's going to be +1. Close absolute value, and then we're going to go 3 up, so that's going to be +3. So that is my absolute value equation for that graph. Number 7, graph the absolute value inequality on a coordinate plane. So I've got a nice coordinate plane here. Some of you guys know how to do this on the calculator. That's fine, you can do that. But I do require you guys be very exact with your coordinates. So don't be lazy with that. Use the table if you need to. But the whole point of doing this is to do it by hand. So y is less than 2/3 times absolute value of x minus 4. So x minus 4 means 4 to the left, 4 to the right. 1, 2, 3, 4. And 2/3, that's my slope. So up to 1, 2 over 3. 1, 2, 3. Up to 1, 2, 3 to the left. So that's going to be my function. But I don't want to, I know that those are going to be the points. But I do need to worry about this inequality. Because it's not equal to, so that means it is going to be a dashed line in this direction. And then, let me do it, 1, 2, 1, 2, 3. A dashed line on this other branch here. And we say less than, so that's where we get some shading happening. No, not something shady, but some shading. And we want to shade the area beneath the graph. This is where all of the possible solutions lie. I could pick any point in the shaded area and it would make that inequality that's up there true. Number 8, solve the equation. So we just did this, but you want to isolate the absolute value. So the absolute value of x is equal to -2. And then notice how I have an absolute value equal to a negative. That is not possible. That's kind of the point of this problem. If you get the absolute value of something equal to a negative, there is no solution. It's a little bit different than what we had to go through with the inequality that we had to a negative. So be very careful on that. Number 9, write the inequality of the function. Is the point -1, 3 a solution? So let's get the inequality first. So it goes 1 right and then 3 down, and it looks like my slope is up 2 over 1. So how am I going to write that? Well, y is equal to 2 times absolute value of x minus 1. So 2 for my slope, -1 to the right, and then 3 down, so -3. But I want to get the inequality, so I need to change this equal sign here. So y, I know that it's a solid line, and then it's shaded above. So solid line and shaded above is greater than or equal to, and just write everything else as we already have it for the transformations. There we go. All right, describe the transformations happening to the parent function in f of x. So let's look at what's happening here. I noticed two things. So this -3 inside the absolute value and then the -2 after. So the -3 inside the absolute value, that means we're going to be 3 to the right. This is good enough. You don't have to say horizontal shift 3. And then 2 down. So the big thing to remember is that if it's inside the absolute value and it says minus, it's doing the opposite of what you think. But if it's outside the absolute value and it's minus, it does exactly what you think. So I know it's kind of confusing, but just if that's throwing you off, go ahead, put it in your notes. Number 11, what is the sum of the solutions? So we need to figure out what these solutions are. So let's figure this out. We'll subtract 5 on each end. So -8 times the absolute value of -2n equal to, so we subtract 5, -80, and then we divide both sides by -8, so I'm going to get +10 on the right, and then the absolute value of -2n. So I get -2n and split it up equal to 10, and -2n equal to -10. So divide this by 2, I'm going to get, by -2, n equals -5. Divide this one by -2, and we're going to get n equal to +5. So what is the sum? Well, -5 plus 5, that gets me 0. So my sum is actually 0. Make sure you go back and you answer, what is the sum? Alright, a few more left. What is the minimum of f of x? So the minimum. The best way to do this is think about, okay, this is the vertex, this is positive. So my vertex is -1, -7. So if I were to draw a graph, it would be 1 to the left and 7 down. And then the 1/2 means it's opening up. So it's doing something like that. So this is going to be my lowest point, my minimum. Well, the minimum value is that y value, and that's going to be -7. You don't need to give me the coordinate, just the -7. Number 13, write the equation reflected. All right, we got to do all that stuff. So reflected, don't forget that one. 8 left, compressed by a factor of 1/2. And this one's confusing because you got to kind of do compression by a factor of 1/2 and then translate it down 5. Okay, so f of x is going to be negative because we have a reflection. The compression by a factor of 1/2 means you got to kind of do that reciprocal because it says a compression that makes it thinner by a factor of 1/2 that makes it fatter. So you're just going to put it 1/2. And then translate it down 5 units, we'll take care of that. 8 units left, so that's inside the absolute value. So plus 8, because the insider does the opposite. And then translate it 5 units down, so then minus 5. That's our function. Number 14, describe the transformation of that from the parent function. Okay, so reflected. We know it's reflected because this is negative. A compression by a factor of 8, because that's there. So plus 77, that does opposite of what you think, so left 77. And then minus 23, that does what you think, so down 23. Sorry. All right, number 15, fill in the table using this function. So for these values, we could just substitute in what we have. 2 times 2 is 4 minus 3, so we get 1 here. The 0, we get 0 minus 3, which is -3. 5, we get 10 minus 3, which is 7. And then the -6, we get 12 minus 3, which is 9. But for these other ones, it can be kind of difficult. We're not going to sit here solving all of them. So let's kind of just put it into the calculator. Let me get mine up and running. It's just going to be a second since I forgot to get it going at the beginning of this video, but that's fine. It's coming. All right, there it is. And let me just add a graph. We're going to put in the function that we're given. 2 times the absolute value of x minus 3. And control T for that table. So what are the values we're looking for? 21 and -1. So I'm just looking for these here. So I could put 1 in for that -1 spot, and the 21 I could do a -12. So -12 here, and then 1. There could be other answers, but we're just going to use the first one that we find. Number 16, again, solving the equation, probably because it's pretty important. The absolute value is already there, so 2x plus 3 equals 3. 2x plus 3 equals -3. and then just solve for x. So minus 3 minus 3, 2x equals 0. Divide by 2, x equals 0. Subtract 3, 2x equals negative 6. Divide by 2, and x equals negative 3. And now we want to go ahead and check those solutions. Always check, even if it doesn't say, always check. So 2 times 0, that looks weird. Eraser. There we go. So 2 times 0 plus 3, the absolute value of that, does that equal 3? Well, I get the absolute value of 3, which is 3 equal to 3. That works. And then 2 times negative 3 plus 3, close the absolute value, does that equal 3? So I get negative 6 plus 3, which is negative 3. Close the absolute value, does that equal 3? Yes, it does, because 3 equals 3. All right, number 17, solve the inequality and graph the solution. Hopefully this one isn't as annoying as the first one we did. So let's look at it. Isolate the absolute value first, so divide both sides by 3. The absolute value of 2x minus 1 is greater than or equal to 7. Split it up, so negative 7 is greater than or equal to 2x minus 1, which is greater than or equal to positive 7. Add 1 to every side, so negative 6 is greater than or equal to 2x greater than or equal to 8. And then divide by 2. So negative 3 is greater than or equal to x, which is greater than or equal to 4. And then when I graph this, I'm going to put the negative 3 and the positive 4. It is equal to, so I'm going to put solid circles. And the direction to shade, well, if I ignore this part here, and it says x is greater than 4, well then, that's this direction. And if I ignore this part here, and it says x is less than or equal to negative 3, well, that's going to be to this direction here. So that's the way to shade. You don't really need to check every value and use all those test points, but you can. The reason I did the test points on the earlier problem is because it was a negative value on the other side. All right, just a couple more. What is the domain and range of this function? Oh, well, this is a transformation. It's not directly stated, but it is a transformation question. And I know that this function is doing something like that, where this is 0, negative 1. So my domain is all real numbers, or negative infinity to positive infinity. You guys need to know that. And then my range, well, that's the lowest y value, which is negative 1, to the highest y value, and it ends in an arrow up. So my range is going to be negative 1 with the bracket to infinity, parentheses, because it's going from negative 1 all the way up. Number 19, find f of 4. We did this on an earlier problem. So f of 4, all that means is the absolute value of 3 minus 4. Close absolute value and add 4. This is going to be the absolute value of negative 1 plus 4. Well, absolute value of negative 1 is 1, so 1 plus 4 gets me 5. No other way to do this problem. And then our last one. This isn't really a question, but just a chance for me to speak. So it says, be prepared to answer questions that you haven't seen before, but to synthesize your knowledge gained from the unit. So think about all those you do questions where it's just really extended y'all's thinking, and you were really trying to figure out what was the question asking, what can I apply from what I just learned. So go back through those notes, go back through those problems, the classwork problems that you were supposed to do and you were supposed to look at. And those are the types of problems that you really need to work through and solve, because those are the types of problems that you could still see on a test. Will the entire test be synthesis? No. But you do need to be able to take your knowledge and apply it in new ways. That's where you really show that you really understand some problems. And that's where you start to get those A's. So if you still have questions on anything here, I hope you like this format where I was going through the review in a video, so you can kind of see how I was thinking through some of the problems. But if you still need some help, come see me during tutoring. You have a couple days before our test. But my name is Mr. Hernandez, and I'm always here to help.